Hey there. Ever watched an AI-generated video and thought, wow, that person looks so real, but how do they always get the lip sync right? Well, guess what? There's a new AI system called Jamflow that's making those magic tricks happen, and it's rewriting the rules of how speech and facial expressions work together. Let's break it down. So here's the thing. For years, AI models treated speech and facial animation like two separate puzzles. One would generate a voice, another would move a face, like two musicians playing different songs. But in real life, when we talk, our mouths, eyes, and even our eyebrows move with our words. Those movements aren't just for show, they're part of how we communicate. That's where Jamflow steps in. Think of it as a team where the AI learns to both generate speech and animate faces, all while keeping them perfectly in sync. How? It uses a clever technique called flow matching. Imagine starting with a blank canvas, random noise, and gradually painting a realistic audiovisual scene. But here's the twist, it doesn't just do one thing. It uses a special architecture called MM-DiT, which acts like a dual brain. One part, the motion DiT, focuses on facial movements, while the audio DiT refines the voice. They talk to each other through joint attention layers, like teammates sharing critical info without getting distracted. What makes this work so powerful? Jamflow can take any input. Need a talking head from text? It can do that. Want to animate a face using just audio? Easy. Even cooler, it can reverse engineer speech from facial movements or vice versa. Picture this, take a video of someone speaking and the AI generates their voice. Or use a voice clip to make a static photo move naturally. It's like giving a puppet a voice and a personality. The researchers didn't start from scratch. They built on existing tools, like a top-tier text-to-speech model called F5-TTS and a facial animation system called LivePortrait. By training these parts together, they created a model that's not just accurate but also super flexible. Whether you're making a virtual assistant, dubbing a video, or just messing around with AI art, Jamflow adapts. This isn't just a technical win, it's a step toward more natural, human-like AI interactions. No more awkward lip sync or robotic voices. Just smooth, realistic synthesis that respects the deep connection between how we speak and how we move. But here's a twist. The same principles that power Jamflow are rooted in a foundational concept of modern AI, transformer attention mechanisms. Ever wonder how models like transformers pay attention to the most important parts of information? Let's demystify this process using a simple analogy. Imagine you're reading a sentence, and your brain automatically focuses on keywords that carry the main meaning, like cat in the cat chased the mouse. Transformers do something similar, but with math. Here's how it works. First, the model takes input data and splits it into three parts. Queries, what we're looking for, keys, where we search, and values, the actual information we want. Think of queries as asking, what's the main idea? Keys as scanning through the text, and values as the answers hidden in the words. But there's a twist. To make this process fairer, the model uses scaled dot product attention. This fancy term just means it calculates how strongly each query matches each key, then scales those matches to prevent numbers from getting too big. The result? A set of focus weights that tell the model which parts of the input to prioritize. Now here's where things get interesting. The model doesn't just do this once, it does it multiple times, like using different lenses to examine the data. These are called attention heads. Each head might focus on different aspects. One could catch grammar, another syntax, another context. After computing all these lenses, the model merges them into a single, cohesive picture. But wait, what if the merged data is too long or too short? The model trims it back to the original length, like resizing a photo to fit a frame. Finally, it applies a projection, a mathematical tweak that fine-tunes the output to match the task, whether it's generating text, translating languages, or creating talking heads. This whole process is what lets AI models handle complex tasks with remarkable accuracy. It's like giving the model multiple ways to look at a problem, and then combining those perspectives into a single, smart answer. And when you think about systems like Jamflow, this attention mechanism is the backbone of their ability to synchronize audio and visual elements seamlessly. But here's the thing, no system is perfect. Researchers found some failure cases that even the smartest models struggle with. For example, if the audio and video don't match in length, the AI can't sync the lips properly. It's like trying to follow a dance routine where the music and movements are out of step. Or imagine if the model sees a cartoon character with exaggerated features or stylized art. Since those visuals don't match real human faces, the AI can't detect facial keypoints, like how a GPS might get lost in a city with no street signs. These aren't roadblocks, they're clues for where we can improve. By studying these gaps, scientists can refine models to handle trickier inputs, like animations or mismatched media. After all, even the most advanced AI is still learning, just like we are. So next time you see an AI-generated video that feels too perfect, remember, systems like Jamflow are making that magic happen. And when you see a model using attention mechanisms to process data, know that it's the same math that powers everything from virtual assistants to deepfake detection. Thanks for watching, stay curious, and let's keep exploring the future of AI together.